welcome. So just a few announcements before we start. So sections, everyone should have sectioned already. Sections normally run from Sunday to Tuesday. So you guys should get your assignments, and then I think next week you'll be with your actual TFs. So if you have any questions or trouble or you forgot to section, some people do that, just let us know. Shoot us an email at heads. Ooh. Then office hours. We started office hours last week. Office hours every week. Monday is in Leverett, 8 to 11. Tuesday is in the Quad, so Cabot, 8 to 11. Wednesday, Mather, 8:30 to 11:30. And Thursday, Annenberg, 8 to 11. So Scratch, a lot of people don't need office hour help for Scratch, which is completely fine. If you do, that's absolutely fine as well. But in the future, the problem sets, they get much harder. So this is going to be your friend. Like, definitely go to office hours. Plan on going to office hours. When you get to problem set 4, 5, 6, 7, like, you need to go to office hours. That's where a lot of the help and the work gets done. I think last year, just for example, on Thursday night, so I think the problem sets were due on Friday. So Thursday night, we would have 200, 250 students at office hours. So definitely make use of these. These are your best friends. Like, this is where, if you're stuck on a problem set, this is where you'll probably get help. So office hours. OK, so those are announcements. Announcements are done. So let's start. OK, the appliance. Did everybody download the appliance yet? No. So. I kind of downloaded the appliance. Right, yeah. So the appliance is new this year. So we're probably going to have some bugs in it. So please download it as early as possible. If you want to, so problem set 1, it's going to tell you exactly how to download it. Getting started installing right here. It's going to tell you how to download the appliance. So definitely download the appliance sooner rather than later. You know, instructions are in the PSET spec. If you download it, so if you wait until Wednesday night and then you have trouble and you send us an email at midnight on Wednesday night that you can't download the appliance, that's not a legit reason for an extension. Like, you need to do it now. And you will have trouble. I tried to download it last night. I ran into a little bit of trouble. If you do run into trouble installing, definitely hit retry, because I just hit retry a couple times, and eventually it worked, which doesn't make any sense, but it does. So definitely retry, but like, if you come up against a brick wall, shoot us an email at heads, and we'll be more than happy to help you guys. What's up?
Just a quick question.
Yeah.
Like the check style,
yeah.
There's like a part that says we didn't include this.
Not yet.
And like says execute it. How do you execute that? Make sure it's like in your system.
You're going to run a bash command. I'll go over that later. Cool. So the appliance, so the appliance can be a little bit intimidating because you're used to kind of running in graphical user interface. So Scratch was a graphical user interface. So what do I mean by that? What I mean is that when you're programming, you're basically using blocks of code. You can see the code and stuff like that. The appliance, you're going to be doing things in a command line environment. And so for the rest of your programming lives, you're going to be doing things in a command line environment. So it's good to get, jump in early and get some experience. So let's do it. So that's Rob. OK, so let's just jump into command line stuff. So this is the appliance. Can anybody tell me why we use an appliance? Like, what is the appliance? Does anybody know? What's up?
Well, it's just like a virtual machine that you run on your machine.
Yes.
So that you can kind of get over the OS disagreements between Mac and PC.
Perfect.
Universal template.
Yeah, it's like a universal template. That's perfect. So yeah, it's a virtual machine. So it's basically an operating system. Like, this is an operating system. This is equivalent to your Mac or your PC or your Linux. This is the exact same. And so you can do similar stuff. Like, if you wanted to, you could go online, for example. You can't really see it, but right here, Google Chrome, you can go online if you want to. This is an operating system. And the reason we do that is because it's much easier when we're handing out instructions and everything. If it's just a uniform environment, it's much easier for us, and it's much easier for you. Like, you're not going to run into like any idiosyncrasies when you're programming. Like, we know exactly what you're going to run into. So the appliance is here. So when you're starting programming, you're going to go down to the left-hand corner. There's a little box. You're going to click it. This is your terminal window. So this is where you're going to be a lot of the semester. So let me kind of zoom in a little bit. OK, so Getting around a terminal window is a little bit different. First, there's no icons. Like, I can't click anything. Like, there's nothing to click. So you have to figure out a way to figure out where you are, what's here, and how to move around. So the two most useful commands probably are ls. So what do you think ls does? List, yeah. Just lists out what's in the directory. And then cd. So let's say I wanted to cd cs50. What did that do? Yeah. Perfect. Yeah, it just changes the directory. So let's go back. So yeah, so how do I go back? So let's say I wanted to go back to the previous directory. Yeah, sure. You can do that. So perfect. So if I write cd, this is actually going to pop me back up to the home directory. So you see this tilde? That's going to pop me up way back up to where the tilde is. So it's going to pop me up back to the home directory. But let's say I did something like this. Let's say I go cd cs50, ls again. I've got other stuff, cd supersection, cd files, so I'm going deep. And then let's say I want to just pop back up to the top, cd. Let's say I don't want to do that. Let's say I just want to pop back up to the directory that was right above me. How do I do that? So let's say cd cs50, cd supersection. So let's say I'm here. Let's say I just want to pop up one time. How do I do that? Yeah, what's up?
Can you just type cd supersection again?
You could do that. Well, I'm in supersection.
Oh, I did that one before.
Yeah, so you could do that. You could do like cd tilde cs50. So if you look here, this is your path right here. Oh, sorry. That's your path. So you could seriously just go cd tilde / cs50. Boom, you're there. What's an easier way to do it, though? That was perfectly correct. But what's a slightly easier way to do it? Because a lot of times you're going to be jumping in directories, jumping out of directories. So let's go back, cd supersection. So let's say I want to get back real quick. You can do something like cd ... That's going to pop you back up real quick. So cd supersection, cd files. Let's say I'm here. Oh, by the way, clear is good because my window is getting a little bit messy. So ls, so I don't want to be here anymore. Cd ... take me one up. Cd ... take me one up. Cd ... and I'm back to my home. Okay, so cd, ls, probably the most important things because you're going to need to know where you are. ls is going to tell you where you are, and cd is how you're going to jump around. You can also do some other cool stuff. So for example, ls is just going to show you the directories in your file. It's also going to show you the files, but it's just going to show you what's there. If you want to do something a little bit more cool, and you're going to actually do this in a couple weeks, ls-l, that prints out a little more information. Can anybody guess what on the left-hand side? The D, RWX, RWX, and stuff like that. Does anybody have an idea what that might mean? Yeah, perfect. Permissions. So you're going to have to deal with this when you do web programming later on. If you've ever gone online and you've clicked on like an image or clicked on a file and it said permission, like permission not allowed or like permission not granted or whatever, that's because when they're programming, they haven't set these permissions to let you to do that. So that's where that comes from. OK, so that's cool. So we've jumped around. We can look at stuff in our directory. But how do we make stuff? Like, I've got directories here. That's awesome. How do I make a new directory? Say I want to make a new directory like for right now. You can do something like this. mkdir. Really, like, so make directory. So what do you want to call this directory?
Awesome.
It's awesome. Awesome. I love it. Make directory awesome. And there you go. So when you list, you have a new directory. And you can tell it's a directory in your appliance because it's got this color, right? So it's, I don't know, it's like a bluish purple or whatever. So let's change. Let's change directory. Let's go into directory. Yeah, what's up? We're going to have, yeah, I'll put them up on, we'll have slides. It'll be a PDF. We'll put them up for everybody. Yeah, sorry, it's like a lot of commands. If you want me to slow down or go back or anything like that, definitely let me know. It's a lot to like kind of absorb right away. What's up?
Can I ask a potentially stupid question?
There's no stupid questions.
There are. What is a directory? You're just looking up information where you store it.
Yeah. Yeah, so like whenever you make it, whatever directory you're in, it's going to basically store it in that directory.
Okay, and then we're calling it from the directory.
But yeah, so the directory is where it lives. So it's kind of like just like if you have a new folder on your desktop and then you write a text file, put it in that folder, like that file is in that folder. Does that make sense?
Yeah.
Okay. Yeah, what's up? Oh, yeah, sorry. The projector's so bad. We had so much trouble with this earlier. Is that better? Is that too big? No, it's not. Is it too small? What's up? Oh, clear. Clear. If you want to clear, just type clear. Clear, enter. Basically, I think on the last appliance, what it basically does, it doesn't clear your information. It just kind of shifts everything down one screen. So if you typed clear, like for example, let's say I'm scrolling up, I can scroll up. This is everything I did. But if I type clear, and then if I scroll up, here's my stuff. So it's not erasing it. It's just basically giving you a new frame. Oh, we'll get there. Slow your roll. All right. Okay, so we're in a directory right now. So David, I think in lecture, he did some cool stuff. So let's like write a program. So you can do that a number of different ways. You can use any kind of text editor. You can use Nano. You can use Vim, Emacs. Those are slightly more complicated. Or you could use something in here. It's called gedit. Sorry. Gedit's not happy. So gedit is basically just like a text editor, just like a text edit word processor or something like that. So it's got a nice interface, just like this. So you do something like that. So actually, let me give it a name because I never did that. So what do you want to name our first program? It's just going to say hi. You lack imagination. Okay, gedit hi. And I'm going to do .txt. Ooh, okay, so here it is. So let's write a program. So in C, I think you saw this in lecture. You need a main function. Boop. So this is just a main function. So bigger? Yeah, sorry. Sorry. Okay, so you need a main function. I think I'm jumping the gun a little bit, but it's never bad to get used to this kind of stuff. So a main function, every C program you're going to write for the rest of this course will have a main function. Does anybody know why? What's up?
Start.
Exactly. So it tells your program where to start. So if you don't have a main function and you compile this and stuff, it's not going to know where to start. Main is always where it starts. So you have a main function. And then does anybody remember how to print? Yeah, printf. Printf, hi. Okay, now I have set you guys up to fail, but will this compile? Why? There's multiple reasons why. Why? Sure. Perfect. So what's this called up here? It's a header file, right? It's a header file, and you're exactly right. Both of you are right. So to include that, I just do pound include standard input output.h. Am I good to go now? Like if I were to compile, would this compile? Why not? Oh yeah, awesome. So okay, so I just made it. So I saved it, but get it or gedit, sorry. Get it? Okay. Gedit hi.txt. So now if I do ls, here it is, right here. Oh, it's not an awesome. I must have gone out. Oh, perfect. How do we put this in awesome? So I don't want it here in my home directory with everything else. I want to put it in the folder. How do I do that? Not too hard. Sorry, I think it cut off. Move. So we've already learned ls to list, cd to change directories, cd ... to bump out of directories, and now we're going to start moving around files. So to move, just move hi.txt, and I'm going to put it in awesome. Just be careful, like whenever you're writing in the command line, everything matters. So like uppercase matters. Like if I had done like lowercase a, it's not going to know what's going on. So everything matters, to be very specific. So run that, ls, it's no longer here. Let's change directory into awesome. ls, boom, it's there. And somebody mentioned why this would not compile. Why is it not going to compile? Again, sorry. Yeah. Perfect. It's not a .c. So how am I going to rename it to a .c? What's an easy way to do it? Let's use the command we just did. So we're just going to do move hi.txt to hi.c. ls hi.c. And then let's just, for fun, let's just jump into this real quick. Let's hi.c. You'll notice it's nice and colorful. Right? So these are just kind of helpful colors when you're programming. So the int and the void, those are data types. We'll go over those in a second. Hi is a string, but useful colors. So if you ever accidentally choose the wrong extension, you should have these colors. So what's up? Oh, I'm going to show you that too. So copy, remove are on the doc. Okay. So let's make this. Just make sure it works. Make hi. Worked. Run it. So ./hi. Awesome. That is your first program. Oh, let me make it bigger. Okay. So a really good question. Yeah, what's up?
Why would it be that when I type gedit, it doesn't give me another line to write gedit hi.txt? It's just like puts the cursor to the left.
Yeah, the JHarp appliance doesn't repeat.
Yeah.
Wait, what? Wait, say that again?
Like when I type gedit,
Yeah.
the first line,
Oh, up there at the very top?
has no JHarvard appliance, and the cursor's just all the way to the left.
All the way to the left?
Does anyone else?
Oh, well, jharvard is just like the username. So that's just like the standard username when you...
It stops responding. So
Yeah.
it doesn't have to break it.
Oh, it stops responding. Okay, so what you have to do is you have to close out of gedit. So close out of gedit, and it should return. So is gedit open on your appliance right now? If you exit out of it, it should return, and you should be good to go. Did that work?
So did you use the first gedit command to open it?
The first gedit command was a mistake. Sorry. The first gedit command, I meant to do gedit hi.txt. So I give it a name. So gedit hi.txt. Hi.txt is the name of the file. The first one was just a mistake. And then I quickly closed out of the program. So the question was if I do like gedit, I'm not going to be able to really do anything else in my command line until I close that gedit. So I think that's what they ran into. So close the gedit. It'll return out of that program, and then you'll be able to actually type in the command line again. Is that good? Dope. Okay. Sorry. Okay. So just make sure to close it if you run into trouble. Okay, so really good question a second ago was copying. So now I have hi.c, but let's say I want to change it. I want it to be slightly better. I want to say hi class. But I want to keep like this template. I don't want to have to rewrite the entire program again. I want to keep the template. How do I copy? Easy. So cp hi.c to new hi.c. Now I have two. And then I can open up new hi.c. And instead of just saying hi, I'll say hi class. Yeah, don't do that. So I'll go back, exit out, go back to my command line, ls, make new hi, run it. There, it's better, much better. So if you want to copy something, easy as that. CP is copy. Yeah. Okay, so we've gone over moving, making directories, copying. Let's see, what else should I go over? Oh, yeah, let's go over this. So this was awesome. Let's say I wanted to, oh wait, let me go back into awesome. Let's say let's say I don't want these files in right here. Let's say I want them in a new directory, like in directory awesome, I want to start organizing. So now I'm going to have a new directory. It's called hi. It's got all the programs that I write called hi. So how do we do that? Yeah. Sorry. Hi. Boop. Oh, sorry. Make dir hi. Dir. It complained because I already had a hi in here. So now I have a hi directory. So now I want to move everything, all the programs I wrote, I want to move them into the hi directory to just clean stuff up. How would I do that? Move again, right? So move. So let's move. Sorry. Move. Yeah.
What's the difference between like hi and the hi.c that we already have?
Oh, hi.c is the actual, so that's the file that you wrote. So if you're going to open it up in gedit or nano, that's what you're typing in. When you compile it, then you get an executable file, that's hi. So if you opened up hi, that's going to be a bunch of gibberish to you. It's basically going to be a bunch of, computer instructions. What's up?
What do all the colors mean? I think blue is probably directory. What's yellow?
Oh, those are the executable files. So when I did make hi.c, it gave me, so I can do it. So jumping the gun, so remove hi, yes. So then let's do ls. I don't have hi anymore. So when you make, that's when you take the program that you wrote and you make an executable file. So make hi.c, well, make hi. You remember, I think he went over this in lecture. These are a bunch of compiler instructions. So instead of having to actually write clang with all these are flags, you just write make. And so this makes the executable file. So when you do ls, now you have hi. So this is what you're going to actually run. And so you run that by doing ./hi, and it runs your program. But if I tried to do that with like hi.c, no, it's not going to work. Yeah, does that make sense? Cool. Wait, I wanted to say something else. Just real quick, in case anyone was interested, when you jump out of a directory, it's the ... Does anybody have an idea what maybe just the regular, so the singular dot means? Yeah.
From that folder behind.
So it's actually the current directory. So it's like your current directory. So let's say, so I'm here, I'm in awesome. If I do cd dot, it doesn't do anything. It takes me to my current directory. So a little redundant, but you have to do that. So ./ your program name, in order to run your program, you have to do that. Okay. So whoop.
If you do cd ... however many dots will it just take you up that many directories?
You mean like cd ...
Yeah.
No. Yeah. So actually, remember I did ls-l? If I do something else, I can do ls-a. So what this says is -a shows you everything. So it shows you things that are hidden and things that aren't hidden. So if you notice that when I did just ls, I just saw that stuff, like the stuff I made. If I do -a, it's going to show me everything. And so current directory above it. Yeah. Does that make sense? Yeah.
But those aren't actually in that directory. Like the current directory isn't in itself, so why show those with stuff that's inside?
You mean it's like it's not in the directory?
Right. I mean, like, so we have the list of things that are in the directory.
I think it is in the directory. Like -a shows like everything, even if it's hidden inside the directory. So I think it's just a route to the current directory. Does that make sense? It's a little recursive. It's like Inception. What's up?
So you said -a shows all the hidden files?
-a, yeah.
Okay, so what makes the file hidden?
Well, for example, let's go back up to the top. It's usually stuff you shouldn't mess with and you don't need to worry about. So like this is kind of the home. If I do -a, I get tons of stuff. Sorry. All that stuff. And, oh, sorry. And you don't need to mess with any of that stuff. Definitely don't start going in here and just like remove stuff. Yeah. Yeah, this was a little bit more comfy stuff, but it's good to know. I think it's good to know. But if you wanted to just if you never want to type -A in the entirety of this course, just forget it. What's up?
What is the ls.-l?
That shows you permissions. Basically, you use that for permissions, so -l. It shows you a little bit more information, but again, this is a little bit more comfy stuff. These are just permissions, so the permissions of the folders. So just for example, let's say I made a folder, and so the D represents directory, so those are directories, and then read, write, execute. So those are permissions for, I think, user, group, world. Totally going too far. You're going to go into this like weeks from now, but just so you know, those are permissions. What's up?
Can you clear it rather than like just skip to the next thing? Can you like clear everything?
You mean like actually delete it? Like, I don't know. I never do that. Why would you want to do that? Why would you do that? I like it. You live on the edge. You're like, I don't want any of this. That's intense. Yeah, so we can do that. It's intense. Oh, sorry, messing with the size is totally freaking me out right now. Let's go up. Yeah, so now I can't go up anymore. So everything I taught you is gone forever. Thank you. Okay. But we still have our so we made our directories, we made our files and stuff like that. So we still have all that stuff. Okay, I'll go fast. So real quick, so let's say I'm in awesome. And let's say I wanted to move everything to the new directory because I just want to organize it, right? So how would I do that? Move, we're going to use move again. So move hi.c. And what you can do is you can just start listing stuff, and the last thing you list is where it's going to move it. So move hi.c, hi, new hi.c, hi, dir. And so it moved everything into the last thing you mentioned. So then change directory, hi dir, ls, everything's in there. So it's nice and more organized. Okay, let's say I hate my original hi program. I want to get rid of it. How do I get rid of it? What's up? No, let's say I just want to remove the program. So like hi, just hi. No, you're right. So it's rm, but you do rm hi. And it's going to give you, it's going to give you a little warning. It's going to say, are you sure you want to delete this? And yes, I do. If you don't want to be prompted like that, because you don't have time, for warnings, remove -f. This is another flag. It's like the -l. It's like the -a. These are just flags that you're giving to these commands. So remove -f. -f means force. So force it. I do not want to be prompted. So remove -f. Let's do hi.c. Just got rid of it. It didn't tell me. But let's say instead I'm done with this directory. I want to get rid of directory. So I do remove hi dir. No, that doesn't work. Sorry. No. So it won't let me remove a directory. Does anybody have an idea? So remove like this. No, right now there's no hi. There's just hi dir. So this is the directory. Yeah. So actually what you want to do is, do you have an idea? I see like a half hand. Okay. Oh yeah. Okay. Okay. That's okay. So if I want to remove a directory, remove -r. That's recursive. So remove that directory recursive. So I want you to go into that directory, remove everything in the directory, and then get rid of the directory. And then I'm going to do F as well, because I don't want it to prompt me with warnings after it removes every single file. So remove -rf, hi dir, boom, it's gone. Just be careful where you use it. I'm going to use it here too, -rf. Awesome. Sorry. It's gone. Be careful where you use that. If you use that here and type something like this, don't ever do that. That will delete everything on your appliance without ever warning you. And I've done that. Like grading prom sets at 4 a.m., I was trying to like remove prom set directories, and I did this, and I was like, oh my god, don't do that. I tried to cancel it. You can cancel Command C, just like canceled everything, but I already deleted like 75%, so I ruined it. And people do that. Everyone does this. Don't do this though this semester. It sucks. I'm like nervous having it here. I'm gonna delete it. Can you imagine? Okay, questions? Yes.
So, what you do, and like everything you're doing here, is this the same as just going into the actual like file, save as, using, and rename everything?
Oh, you mean like through gedit? Yeah, it is. Gedit's useful, but so gedit's very useful. In this class, you can do a lot of things through gedit. You can save, you can rename, you can move files and stuff like that. But just truthfully, you know, when you go to 50, 51, well, you're at 50, 51, if you go to 61, like this is going to be your life. Like this is the command line. This is where you will program for the rest of your life. So, you know, definitely use gedit if you want. Like, definitely a good way to start. Like for the first prom sets, definitely use it. But, you know, every once in a while, try to get more comfortable with command line arguments. But you can, definitely. What's up?
So we want to delete one of the files we've made.
Yeah.
There are two ways. Either ask for a prompt or they don't.
Yeah.
Is there a way when you're deleting a directory to ask for a prompt so you don't end up deleting
rm-r. So don't force it. So rm-r, it's going to go through recursively, delete everything, prompt you after everything, which like will drive you nuts. Like I almost exclusively do rm-f and rm-rf. Just constantly, I'm like, I don't have time. I'm a busy man. All right, what's up? Yeah. No. I could go back and like get my appliance that I just deleted. No. If you do RM, it should be gone. What's up? Yeah, just like that. So for example, you saw the rm-rf. Let's say I want to do ls-la. It shows me everything. Sorry. Shows me everything, even hidden things with their permissions.
So then R, the dash R flag, does that, if we don't have that, we can't delete a directory, right?
Right.
So that says that we want to do something with the directory. Is that
What that means, dash R, means recursively. So a directory, like it's going to have files in it, right? So what you want to do is you want to go into that directory, delete everything, all the files in that directory, then pop out and delete the actual directory. So the dash R means recursive. Do it all recursively. If that makes sense. Yeah.
Directory is empty, and you just delete it, or do you still need the...
Let's try. So make dir empty, remove empty. Nope.
So you still need the...
Yeah, always. So dash R, dash RF, empty. Awesome. Any more questions? I think that is your crash course on command line stuff. Any questions? Because we're going to jump over to like data types and loops and all that stuff. What's up?
I don't have CS50 shown as one of my directories. Is that normal?
Oh, yeah, that's mine.
Oh.
Yeah, that's like where my solutions to your stuff is. So, yeah, that's absolutely normal. I think you'll probably just have these four. I think that might be normal. Yeah. Okay, any more questions? I know that was like super fast. What's up?
I saw the blue-green color. What was
That means directory.
this blue?
Oh, you mean this blue-green?
No,
Oh, this blue-green?
no. When you listed all
Oh.
with the
Uh,
files of all the,
like this?
yes, the icons.
Oh, this? I don't know. What does that mean? Okay, so it seems to be pointing to a directory.
Almost looks like an alias.
It might be. You don't need to know that. Okay. Any more questions? Awesome. If you have any questions, I know that was a lot. A lot of this information will be online. I'll put it online for you guys. Section video will be online as well. Or if you have questions, just come up and ask me. But, oh, sorry. There you go. Okay, so now Sharon and Hannah will go over some of the logic behind problem set 1.
Yeah. Troubles.
In the meantime, I'm Hannah. This is Sharon. We are both CS50TFs, and we're going to give you a little intro on a couple important things for problem set 1, everything from data types to conditionals to for loops. Loops in general.
And in the end, we will take a look at pset 1 and what you have to know for it. So let's start with data types. Some of you guys should be familiar with the ones that are highlighted in blue. So we can start with ints. Ints are integers, so like 1, 2, 3, 4. Floats, floating points, like integers with decimals, so 5.2 or even 5.0. Chars are characters like A, B, C, and a string, you guys all know, like CS50 or hello and world. Bool is a Boolean, so we have true and false as our Boolean. So if something computes to true, if 5 equals 5, that computes to true. And if we have 5 equals 4, that's false, so that computes to false. And here we have the associative size of all of these data types. And you will have to know this for your quizzes, so this might be helpful to remember. But we'll post these. Actually, they're already posted. So you should be familiar with the ones highlighted in blue. I think that's good.
Oh, real quick. Just in case you want to know the difference between like char and a string. So when you're writing stuff, whenever you have something like quote, quote, hi, that's going to be a string. So if there are 2 quotes, it's a string. But if I were to do, so like if I were to do H like that, that's a string. But if I only have 1 quote, that's a char. And so what's the difference, you might ask? Well, the difference is this is 1 byte of memory. This is 4 bytes of memory.
Yeah.
Float.
Float? Describe it again. Okay. It's kind of like a number that has a decimal point with it. So 5.2 or even 5.0 is a float versus just 5 is an int. Oh, it can have many decimal points. So 5.6752, 3.1415. Yes. Yes. Huh? Oh, you don't have to worry about the white ones just yet.
The notes are posted at cs50.net/sections.
Just out of curiosity, is there a utility to knowing the size of the files you're calling? Is that why we should know it?
So these are the data types, but yes, so in this case, which one would take up more memory or more space?
So for concrete example, and I think problem set 4 or 5, we're gonna give you a bunch of data, and you basically have to traverse that data. So it's useful to know that if you have so many integers, that's going to be what? So let's say I gave you 10 integers. What's the size of that? It's 40 bytes, right? So you might need to know that, okay, I need to jump 40 bytes. So let's say I gave you, instead it's 40 chars. Then, or let's say I gave you 10 chars. Then you need to know, okay, I only need to jump 10 bytes. So it's very useful to know the size of the actual data types, because a lot of times you'll be jumping around the data, so you need to know how far to jump. So yeah, yeah.
What's the difference between the 2 quotes and the 1 quote?
Okay, 2 quotes is a string, 1 quote is a char. So
Like operationally, they both say hi.
oh, sorry. This is just H. Sorry, this is not clear.
So the top one, it's
This is a string, yeah. So it's 2 characters, right? String, hi. But let's say I just had a single character. If I put 2 quotes around just H, that's a string. This is a string H. Does that make sense? So this is 4 bytes. Let's say I got rid of that and only put 1. Sorry. Like 1 quote. This is now a char H. So exact same thing, different data type. This is only 1 byte, whereas the string was 4 bytes. Yeah.
So if you were trying to store a word like David, you would want to use a string because regardless of how long the string is, it will only take 4 bytes unless it's a long, and or a double. In which case, like so, if it extends beyond 4 characters, then you want to make it into a string. Is that the general logic behind? Is that
if it extends beyond 1 character, it's a string. Like
so there's no operability to storing like a 4-letter word as 4 individual, or a 3-letter word as 3 individual characters, because that'll only be 3 bytes as opposed to the 3-part string.
You could do that. You could do that. So, but I don't think that's really worthwhile because you're only saving like 1 byte. You know what I'm saying? And in the big scheme of things, it won't really matter. But for example, print F is let's say you're printing F and you have 3 chars. You can print that at, let's say you have CAT. You can print F cat just by doing like 1 char, 1 char, 1 char. Or can you print F string cat? It's the exact same thing. So you could do it like that, but the amount of
That's
saving.
not gonna save you that much.
Yeah, the headache that it would induce. It's not worth it. Yeah.
For like the example you had, the H with 1 versus 2, the single or double quotes.
Yeah.
Why would you even want to save a single letter as a string? What purpose does that ever serve?
I don't know. I mean, it really depends on the program. You know, for example, I think later on you'll get into like command line stuff. So like, for example, instead of me asking you for an integer, sorry, am I speaking to you?
Yes.
Sorry. So like, for example, instead of like me asking you for something with like a get end, which I think you might have seen in lecture, there might be a command line. You just type it into the command line. So it'd be like --hello 4 or something like, or hello H, whatever. You do it at the command line instead of being asked for it. That command line is always a string. Whether it's a 4 or an H, that is always a string. So that's one example of when you might have a singular letter or a singular number represented as a string.
Okay. All right. Okay, and then here are some basic operators. Hopefully you're familiar with the first 4 just in general. So there's adding, subtracting, multiplying, and dividing. And make sure you use the right keystrokes. And then there's also modulo, which some of you might not be very familiar with. And what modulo does is that if we take this example, 4 modulo 2, it takes the remainder of what that does in division. So 4 divided by 2 is 2, and there's no remainder. 4 divided by 3 is 1 1/3, and so remainder 1. So it computes to 1. And then 4 modulo 5 is the fraction 4/5, and the remainder is 4. Does that make sense? Okay, cool. And we follow PEMDAS here, too. So some Boolean expressions. So you guys have seen equals equals to compare, like, say, 2 numbers. So if 5 equals 5, that computes to true. Make sure you have only 1 equal sign. For not equals, it's bang or exclamation.
2 equal signs when you do equality.
Oh, yeah, make sure you don't have 1 equal
yeah.
sign. Yeah. And then for not equals, it's bang equals. And then you can look through for less than, greater than. And then we have logical and logical or right here. And what that does is, if you remember in Scratch, when you had that block that said and then you could fit 2 different pieces there, that's what this and does. And make sure you do 2 ampersands. And this key you can find, it's like towards the right under your delete button. Question?
What will the 49 equals and 3 ampersands? Like, watch them
So for if you only do one, you're comparing bits. If you remember what bits are, they're like zeros and ones. And so that's comparing something else. So we're going to focus on this for now.
So 1 equals is like assignment, right? So like int x equals 4. You're saying that variable x equals 4. So 1 equals is assignment. But the ands and the pipes or the bars, just like Sharon said, they're bitwise operators. You don't need to worry about that.
When do you use logical and logical or again? I just forgot when we do that.
Sure. So if you ever want to check if two things are true, for example, let's say I want to check that a number is between 5 and 15. I would say make sure that the number is greater than 5. So let's say if x is greater than 5 and less than 15. So you want, in order for that whole statement to evaluate to true, you need both of the kind of sub-statements to evaluate to true. With or, you only need one of the two, or both.
And also in Scratch, I'm sure in a lot of your projects, you had if touching the edge, or if touching another sprite, then bounce or something.
Cool. All right, so why do we care about all of these Booleans? We have these structures that you've seen in Scratch called conditionals. And conditionals are anything of the form, if some condition or some Boolean is true, then do the code between these curly braces. So you can see on the right, here's the Scratch block. You have this if, then, and anything that goes into that little shape that looks like this, I don't know what you would call that, that's going to be the Boolean or condition. So again, a Boolean or a condition is anything that can either evaluate to true or false. And again, you can combine Booleans. You can have, again, like x is greater than 5 and x is less than 15, or you could just have one of those, x is less than 5. Okay, so in C, it's on the left. It's just the keyword if, in parentheses, the condition or the Boolean, and then the code in between those two curly braces will only execute, will only run if that condition or that Boolean is true. Does that make sense? Awesome, okay. And then as you may have seen in Scratch, we can also add on an else, which is basically anything between the curly braces under else will only execute if the condition is false. Make sense? Any questions on these two? Awesome. Cool. So here's a quick example. Let's say we want to determine the time, or based on the time, decide whether we should say good morning or good evening. I'll say if it's before 12 noon, we're going to say good morning. Otherwise, we're going to say good evening. And when I said that otherwise, that's equivalent in C to this else. So we're going to check if the military time is less than 12, say good morning. Otherwise, say good night, or good evening. Yeah.
And we'd actually get that input for military time with like the get string.
Right, somewhere else we'd actually have to provide that information. Right here, it has no value. We never even declared it. I assume that somewhere above this program, I declared the time, or I asked for the time. Or cool. Anything else with this example? Awesome. Okay. Now we have, in addition to that simple if-else format, we have two other different structures. So first we have the switch statement. And here's the general form of a switch statement. You have the keyword if, the same way you have you have the keyword switch the same way you have the keyword if. And then an input, in this case n. So this can only work with integers. So that input n has to be an integer. Okay? And we're going to follow one of these cases depending on what that value n is. So in this case, you first compare, is n equal to constant 1? If it is, do everything kind of indented over here. I can't point to it because I'm too short. If it's not equal to constant 1 and is instead equal to constant 2, we're going to follow that second block, and we can do this for as many times as we want. And then that default is, if it didn't match any of the above cases, execute that code. Any questions here? This one's a little more complicated. Yeah?
Break signifying what?
Sure. So once we enter that block, if we find, let's say our n is in fact equal to constant 1, we enter that block after the colon. We do whatever is on that line of commenting, and then we break, meaning we get out of this switch statement entirely.
Okay.
Yeah.
Is the indentation necessary, or do you need curly braces or anything for those cases?
Sure. So as always, indentation is not strictly necessary. The computer doesn't care whether you indent. We, as people who are reading your code, do care. So it's a lot easier to look up at this screen and see, oh, I know exactly what happens when n is equal to constant 1, as if I had random indents, I wouldn't be able to tell so easily. Yeah?
So if we wanted a user to choose one of the options that we have on the list, would we, like, I guess we'll learn this later, but get an integer from them and put that into n?
Exactly. Exactly, right. So we could, let's say we wanted to check what integer. We said, enter an integer between 0 and 5, let's say. We could ask for that n, ask for that value, and then have each of those cases. And again, this is something we could very easily do with if statements, right? We could have if equal to case 1, if equal to case 2, if equal to case 3, so on and so forth. This is a little bit faster and a little cleaner, and it's kind of just a nice structure to know.
Faster as in writing? What does it run the computer versus faster?
It runs a little faster. Yeah?
The double dash is just a comment? Or
Oh, yeah, I'm so sorry. I didn't point that out. Okay, if you have that // is a comment. So just // is a comment. So anytime the computer sees that, it's going to say, okay, anything that follows this, I'm just going to ignore. I'm going to pretend you never even wrote that.
so this specific thing doesn't really do
This does absolutely nothing. But if I wrote something like, instead of that comment on the first comment, I wrote instead printf, say congratulations, you entered constant 1. That would be something. Yeah.
So in real life, the case constant 1 would just simply be a number, and then the case constant 2 would be another integer.
Exactly.
Do you need the ellipses?
Sorry?
Do you need that?
Oh, no, I'm sorry. That was just to indicate that you can go on for as many cases as you want. Let's do a concrete example. That might make things a little more clear. Okay, so let's say I say, okay, give me an integer n that represents a class number, specifically a computer science class number. So if you give me 50, I'm going to say, great, CS50 is an introduction to computer science, and then I'm going to break. So that means I jump out of this whole switch statement. So now I'm done running the code, okay? If you gave me instead 51, I'd print the second statement. And then if you gave me some number that wasn't 50 or 51, I'm going to say, sorry, I'm not familiar with that class. Yeah?
You don't have break.
I'm sorry, I don't have break.
What if?
Oh, what if you don't have break? Excellent question. So what would happen is you would go in and you would check, am I equal to 50? And let's say, yes, you were equal to 50. You'd print the statement, and then you would continue executing. So you would say, am I equal to 51? And you would go on and go through every case like that. Yes.
Is the default line analogous to saying else?
Exactly. Very good. It's like the kind of catch-all.
So if you didn't have break, and then one of the case statements was true, and then it said increase n by 1, then it would automatically make the next one. It would check case 51 and then display that as well.
Yeah, I think that would work. Right. So you could kind of get messy. So break is a good thing to have. Yeah.
Without break, would it do the default?
That is a good question.
I think it just runs. So if you don't have break, so let's say I did 50, it'd check 50, and print that F. Print F, CS50 is introduction to computer science. You don't have break, it's just going to go and keep going until it hits a break. So if there's no break, it's going to keep going. It's going to print everything else out.
So I guess that would be including the default.
Yeah.
Good question. Yeah. I'm sorry? Is case considered a function? I would
No.
hesitate to say that, yeah.
Yeah, so normally when you see functions, they'll be in curly braces. So for example, when you look at your code, for example, main, it was main, open paren, then void, close paren. Functions are almost always, they're basically always, you'll see parentheses. So case doesn't have any parentheses. That's your clue that that's not a function. Yeah, but it's not.
Cool. Yeah?
So then does that make switch a function?
Does that make switch a function?
In the sense you put something in, it gives you one of the cases.
I wouldn't call it a function. Not everything with friends is a function. But, that's a clue that it is a function. I wouldn't say switch is a function because it's not really returning anything. You'll get into that more, but yeah.
Yeah, just think of it as an if structure.
Can you nest this in an if structure? So if, okay.
Yeah, you can nest pretty much anything. Yeah.
Barry said default is sort of the same as else.
Mm-hmm.
So can you replace default with else?
Can you, not in this particular structure because this switch statement is expecting the word default. The computer knows that default means something special. That means the catch-all. Anything else on this? We have one more to get through. Yeah? difference between using a semicolon and a colon. So a semicolon is always to tell the computer, I am done with this line, you can go ahead and execute it. This is a complete line. A colon is going to, in this case, bring you into a particular block. So semicolons are always used to end lines. Colons are used for a variety of other cases.
Is this equivalent to just saying if n equals 50, then blah, blah, blah?
Mm-hmm.
It's just the same, it's just a more stylistic method to do that.
Exactly, and we said it runs a little bit faster. If we did not have the break, it would be like if. If we do have the break, it's like if, else if, else if, else if. Cool?
So when coding, you can just use if else, but I think last year on the quiz, we had them write a switch statement, so just in case.
Yeah. But definitely nothing wrong. We're not expecting you to worry about like performance, crazy things. So just if else is totally fine. These are just good things to be aware of. And here's our last one that kind of falls under this conditional category. We have something of the general form, condition, question mark, and then a little piece of code that happens if the condition is true, and then colon, a little piece of code that executes if the condition is false, semicolon. We're done with that line. So syntactically, it's a little bit ugly. We're going to go through an example. I think that's most clear. So we want to assign the string professor to one of these two values, either David Malin or not David Malin. Okay? So you should be familiar with the string professor equals. We're going to assign a string to the variable called professor. Okay. Now we want to check a particular condition. In this case, our condition is class num equal 50. And now might be a good time to point out, when we have string professor equals, that's one equal sign, that's assignment. Whereas in class num equals 50, that's two equal signs, that's an equality check. So we're going to say, is the class number equal to 50? If so, assign professor to David Malin. If not, assign professor to not David Malin. Any questions there? Again, this is just something that's good to know. You could do this with if-else. A good practice problem might be to, when you go home, write this same exact conditional in an if-else form, because you can do that. Any questions here? All right, I think we're going to go on to loops. Awesome.
Okay, let's talk about while loops. So first on the left, you see here, oh dear, okay, that says while, while condition, and then you do this. Can we change this one?
It's cut off.
Okay. Okay, and then there are also curly braces, so pretend that curly braces are there above and below the do this again and again. So if the condition in that in those parentheses evaluates to true, then you should keep doing whatever is in the while loop. So for example, we could do a practice problem. Let's say I'm wearing 2 earrings right now. So let's say if I'm wearing at least 1 earring, clap your hands. So if we're going to go through this, we're going to, right? And I'm wearing 1. Okay. Yeah, I'm not wearing earrings anymore, so no more. Okay, so then that's when you would stop. And this, you could say, is equivalent to almost variables. Let's say you have a variable number of earrings. And so while number of earrings is greater than or equal to 1, clap hands. And then after clap hands, decrease or decrement earrings, do like earrings minus 1. So like decrement the number of earrings. And then we'll go through the while loop twice. And if the condition is always true, so if, let's say, 2 equals 2, and that 2 is always equal to 2, right? Then you would always do something in there. And that's equivalent to almost the forever loop that we had in Scratch. Yes?
So the 2 sides just different ways of writing a while loop?
So we're focused on this one first. And then so let's compare it with a do while loop. So they're slightly different, okay? So let's say the condition is still while I'm wearing at least 1 earring, and I'm not wearing any earrings right now. And let's say do and still clap while I'm wearing at least 1 earring. What should happen? Uh-oh, guys. Okay, so you're supposed to clap once because basically you go through the first part of the code. You do it no matter what, and then you see the while condition, and you go back into that loop if it's true. Does that make sense? You always do it the first time. Yeah, regardless of whether or not that condition is true or not.
When do you think you'd use this? When does it make sense to use this?
Yeah.
Right.
Very
exactly.
good.
So when you prompt a user, so you're going to always want to prompt the user one time. Sorry. You're always going to want to prompt the user one time. So instead of putting in a while loop, you put in a do while loop because you're always going to do it one time. If they give you the correct answer, you're done. If they don't, then you reprompt them.
All right, for loops. So in Scratch, we had repeat blocks. So we wanted to repeat something, let's say 7 times. So we just said repeat 7 and say, I'm here to help you, Snow White. In C, we have for loops. If we want to go through something a specific number of times, let's say if we initialize the variable dwarves and so the first block right there, before the first semicolon, we initialize our variable and we set it to 0. And our variable there is an integer, int. And the variable name is dwarves. And we set dwarves to 0. And the second part, between the two semicolons, is our condition. And so as long as dwarves is less than 7, we'll keep going through this for loop. And then the last part is, what do we do at the end of this for loop? Dwarves plus plus. And that means we increment dwarves by 1 every time. So what's going to happen here? So first we're going to go through where we have dwarves as 0, and then we're going to print, I'm here to help you, Snow White. And then dwarves is going to increase because we said dwarves plus plus. Dwarves is going to be 1. And then we compare dwarves is 1. We compare it to, is dwarves less than 7? Yes. I'm going to go through this again. I'm here to help you, Snow White. And then dwarves becomes 2. And then we compare it. Dwarves is 2 less than 7? Yes. We're going to keep going through. And we're going to go through this 7 times. So in the end, we're going to have dwarves equals 0. Print out, I'm here to help you, Snow White. Dwarves equals 1, 2, 3, 4, 5, and 6. Remember, we index at 0. So we start with 0. Yes?
And this is different than the do loop because this doesn't print out initially at first. So couldn't you do the same thing? Could you do this also with the do loop? Like the same process? Like
So,
the condition is like dwarves is less than 7 or whatever, response is less than 7.
so you could technically, so if we go back to, you're talking about the while loop, right? So the do while loop is slightly different because we guarantee at least once that we'll go through it. So that's the biggest difference. But with the while loop, we could say dwarves is, while dwarves is less than 7, do this, and then increment dwarves by 1. And then we have to initialize dwarves before this whole statement that it equals 0. So yeah, we could do that with that.
Can you go back to the next screen?
For loop?
Yeah, so with the dwarves plus plus.
Yes.
It seems like, so that's what you do after you've ran stuff underneath.
Correct.
So could you just not have that and put it?
You could. Yes.
So like instead of having
But
it up there, have it right after the printf in the next line underneath.
yes, you could put it there. But then you would just leave that empty.
You still need the semicolon, though.
Yeah.
You just don't need
It looks a little awkward, but you could technically do that. Technically. Please don't. Yes.
Are there any alternatives to plus plus? Is there anything else you would want to use that?
So technically, it's oh my goodness. Technically, it's dwarves, and we're gonna 1 equal sign. We're gonna set it to dwarves plus 1. So technically, that's what doors plus plus means. Does that make sense?
Yeah, but are there any alternatives? Like, would you ever?
Oh, yeah, you could do doors minus minus. Yeah, you could do a host of things.
And you could increment by 2, you can increment by 3, anything that's going to be changing, that'll eventually make the condition.
So if you wanted to increment by 2, how would you write that?
You could either write dwarves, you could write this whole thing out, dwarves equals dwarves plus 2, or a slightly shorthand, I'm just going to write D equals, plus equals 2.
Okay, and you write that right where dwarves plus plus is.
Exactly.
Correct. There's another question? Yeah. So you don't.
Yeah, you don't need,
you don't need it
it's
there.
at the very end. So you do semicolons because you're kind of splitting up the initialization, condition, and the change. But at the very end, you don't need it.
Also notice you don't need the semicolon after the whole entire for loop.
How would you start with an initial number of like a negative, for example?
You can initialize dwarves equal to -2.
Would you just do dash 2?
Yes, so the negative sign -2. Yes.
Is this equivalent to initializing dwarves earlier?
Yes. So if we had just initialized dwarves earlier, just do int dwarves, semicolon, and then there we can do dwarves set equal to 0.
Okay. Could we do it earlier in the program saying int dwarves equals 0 and then just delete
Just not have, so there would be a space again, but you would still need the semicolon. Yeah. Mm-hmm.
Does this code say what the value of doors is afterward? Or do you ask it after all this is done to print the value of doors?
You could ask it to do that.
Okay.
But you would have to ask it to do that.
Right.
It doesn't do it for you. I'm like scared to put my earrings back in. Because you can't. Do it at the end for the applause. Just kidding.
So that's the same. So initialize at the top, condition, print, change. So this is exactly the same as that. If anybody can see that.
Why don't we have the semicolon after the first line?
Where?
After the first line.
After the for and the parentheses. Because we want to go through into this loop. And if you take a look at loops in general, they don't have semicolons. Except for after the one. Are we good? One more question? 2 more? Yeah.
This might be a little bit advanced, but does the dwarves have like a different scope than like a variable you set you initialize outside of the loop?
Very good.
It's only usable inside the loop?
Yes, it is. What?
Yeah, so it does. So like normally like the scope of something is in the curly braces. So scope's always going to be in the curly braces, but that wouldn't make much sense for the for loop. So because we initialized dwarves in that curly brace. So normally the scope of dwarves, that variable, wouldn't extend past that. This is a special case though. So you initialize it within those parentheses, and then you have the scope later on. So special case. They used to not have that, and that was, yeah. Does that make sense?
Yeah.
I go. So what are you still confused about?
As in, like, can you use dwarves? You can obviously use dwarves inside the music curly braces, but you can use it outside the curly loop too.
No. So it's only the scope of it is only inside the curly braces for the for loop. Yeah.
But if you initialize dwarves outside of the for loop, then you can use it elsewhere. There's one more question? No? Okay. Okay, so we talked a little bit about nesting for loops or nesting conditionals, if statements. So here's an example of where we could nest a for loop. Let's say we're printing this table of x's right here. We might want to first, if we don't look at the code and we just think about it, we want to go through every row and print each column, right? Does that make sense? Okay, so here we're going through every row for basically each row, and there are 3 rows. And then within each row, for each column, and there are 4 columns, print an x. And so when row is 0 and column is 0, we print this x. And then we keep going through the column loop. And then row is still 0, but column is 1. And then column is 2, and then column is 3. And then we exit out of that loop because then column is no longer less than 4. And then we print a new line. And we go to the new line. And then we go through the next row. And row gets incremented. And we go through that again. Does that make sense? Yes.
So to nest, all you do is just put it inside of the for loop.
So nesting means that we have like a for loop within a for loop, like inception.
And you don't need like a special notation or anything. You just stick it right inside of it.
Correct. Yes.
This might be nitty-gritty, but it looks like there's an extra space between all of the X's. I don't know if that would actually, if you were to do the program, would it do something like that?
So no, that was pressing enter. Sorry, that was bad on our part. Yeah.
How would
Apologize.
you change this program if you did one extra line?
Yeah. Good job.
So you can also print the same thing by switching row and column, right?
Hmm?
So like to print your little XXX, you can also say the first line can say print, and instead of saying row, it says column.
So you can change the variable names to do that? Is that what you're saying?
No, I'm just saying that like, so you're printing rows first and then printing columns. Can you also print columns first and then rows? And to get the same diagram.
You could, but then you would have to be careful where you put the new line. And how would you jump back? Yeah. Right? You jump
Right.
back.
So like if you just switched it and the values were different, instead of having I think like a 3 by 4, it would be you'd have 4. Sorry. You'd have 4 rows and 3 columns. Does that make sense? Yeah. So yeah, you could do that.
Okay.
Yeah, definitely.
But that would be literally just switching the names of the variables. Yeah.
Yeah.
Good? Okay. All right, piece set 1. Okay, so the first part of it, you will be doing this, Mario. I'm just kidding, it's more like this. And so when we just looked at the nested for loops, making that table, think about how you might be able to print out these hashtags in this way. And then right here, how would you print this right here, this open space? Yeah, you just print a space. Okay, so just think about that.
And then the second part of the problem set is a program called greedy.c. So that you're going to want to think about conditionals and making sure that you can make proper change. And one little warning we have for you is be careful of floating point values. If that means absolutely nothing to you, it'll be covered in lecture this week, and also in Zamila's walkthrough, which you guys will learn to love on the problem sets. One thing that I really suggest, especially with Mario.c, when you're doing the problem set, if you get stuck, start by doing it on paper. Write it out, and actually sit there and pretend to be the computer and go through. Say I were the computer, how would I follow this for loop through? How would my variables in the for loop change? So doing it on paper makes it 10 times easier when you go to sit down at the computer. So just a little plug.
And also don't think that you have to code everything all at once. Make sure you take an iterative process, like do a little bit, print it out, see what happens. Sometimes it's a little trial and error.
And come to office hours. Yeah, super fun.
So any questions? All right, guys, that was your first section.
Thanks for coming.
Thanks for coming.
Thank you.